after Christmas break, we're going to have a semester exam. So we're going to review several things that will be on that exam. We're going to review that today. We're going to review it Monday and Tuesday of next week. And then we will review after break as well. So to do a quick review of the systems, we've got this assignment here. So if you've got a problem like number one, both of these equations are equal to y. So that means they equal the same thing. So that means they equal each other. So you can simply take the first equation and set it equal to the second one. So there's the first one. I'm going to set it equal to the second one because they both equal y. You can think of this as substitution. You're taking this equation and plugging it in for y. And then once you got them set equal to each other, you just solve for x. Now, most of you probably don't like to deal with fractions, so to get rid of the fractions, what you can do is multiply both sides by the denominator. So if I multiply both sides by 3, okay, when I distribute into 3, the 3 on the bottom of the fraction is going to cancel. So I'm going to have negative 7x all by itself because the 3 just cancels. And then 3 times negative 4 is negative 12. And then when I distribute it over here, I'm going to cancel that 3 on the bottom again. I get negative 2x. Distribute it over there, so I have plus 3. Now I have a simple equation to solve for x. So you can move the x whichever direction you want to go. So if I add 7x to both sides, it's going to cancel those. It's going to leave negative 12 equals negative 2 plus 7 is going to be 5x, and then plus 3. And then to finish it off, I'm going to subtract the 3, and I've got negative 12 minus 3 is negative 15 equals 5x. Last step is to divide everything by 5. So I have x equals negative 3. And for each of these systems, we're talking about lines, we're talking about a coordinate grid, so we need an x and a y value. We need a point, need a coordinate. So once you got your x value, you plug that back in into the equation to find the y value. It doesn't matter which equation you use, I'm just going to pick the top one there. So I have negative 7 over 3 times x, which is negative 3, minus 4. So now I just evaluate this. So when I multiply fractions, I can put that negative 3 over 1 and multiply the top of the top. So that's going to be a positive 21 over the bottom times the bottom, which is 3. 21 divided by, I can drop that negative 4 down, but 21 divided by 3 is 7. 7 minus 4 is going to be 3. So that's the y value. So now I've got the x comma y. Okay, another type of system is when they look like number 3, and then the last is when they look like number 5. So when they look like number 3, you want to solve with elimination because everything's lined up, and to eliminate you need to multiply one or both of the equations to get the same number but different signs. So this one I'm going to multiply the second equation by 2, so that when I distribute this 2 to the negative 6, it's going to give me negative 12, which will cancel with the 12x above it. So I'm going to distribute that 2, and I'm going to write what I get over here. So negative 12x positive 14y equals 10. That just comes from multiplying everything by 2. And then I'm going to rewrite the first equation. And then I'm going to add the equations together. So since I have opposites, I can cancel out the 12x's, 12x minus 12x, and because they go to 0. Right? So then negative 10y plus 14y is 4y equals 10 plus 10 is 20. Now I just solve this for y by dividing by 4. So I'm going to have y equals 5. And then once I have the y value, or if I found the x value first, I would take whatever value I found and plug it in for y into into one of the equations. So I'm just going to plug it into the bottom one there. Doesn't matter which one you choose. So where the y is, I put the 5. So now I'm going to evaluate this for x. So I have 7 times 5 is 35. And then drop that negative 6x down, and now I solve this for x. So I'm going to take and subtract that 35. That's going to cancel those, drop to negative 6x equals negative 35 and 5 give me negative 30. And then to finish it off, I'm going to divide everything by negative 6. So x will be positive 5. So now I have my x comma y. So that's what I'm looking for. Forgot the parentheses. Okay, then number 5 is a substitution type. So when one of them is solved for the variable, or both, like the first one, when you have them solved for the variable, then what I would do is substitute in for that variable. So the y in the second equation is going to become the negative 7x minus 22. And then I'm going to solve for x. So I'm going to take that negative 6, distribute it in there. So that's going to give me a positive 42x. And then negative 6 times 22. It's going to be a positive because it's double negative, 132. So I'm going to drop the negative 6x at the beginning, drop the equals 24. Once I've got that, now I'm going to combine my like terms and solve for x. So 42 subtract 6 is going to be 36x. Drop the plus 132 equals 24. Now I'm going to finish solving, so I'm going to subtract 132. It's going to cancel those, leaving 36x equals 108, negative 108. Then the last thing I need to do is divide by 36. When I divide by 36, I have negative 3. So that's my x value, and then I plug that back in to find the y value. Now I can plug it into either equation. It's going to be a lot easier for this one to plug it into the first equation because the y is already by itself, but it will work either way. So I have y equals negative 7 times negative 3 instead of x minus 22. And now I solve it. So negative 3 times the negative 7 is going to be a positive 21 minus 22. So y is equal to negative 1. So now I have my x comma y.